In section 2.3, we are going to look at linear functions and their slope. So the objectives for this section are, after studying this section, you should be able to 1. Calculate a line slope. 2. Write the point slope form of the equation of a line. 3. Write and graph the slope-intercept form of the equation of a line. 4. Graph horizontal and vertical lines. 5. Recognize and use the general form of a line's equation. 6. Use intercepts to graph the general form of a line's equation. And 7. Model data with linear functions and make predictions. The slope of a line. Is there a relationship between literacy and child mortality? Looking at this graph, we see as the percentage of adult females who are literate increases, does the mortality of children under 5 decrease? So the percentage of adult females who are literate is the horizontal axis. That's the input. The vertical axis is the mortality of under 5 children who are under the age of 5. That's the output. So we have a relationship, it appears, between the input, the percentage of adult females who are literate, and the output, the mortality of children under the age of 5. Data presented in this visual form is as a set of points is called a scatter plot. So if you have a set of ordered pairs and you graph that set of ordered pairs, you have created a scatter plot. Also shown is a line that passes through or near the points. A line that best fits the data points in a scatter plot is called a regression line. So the line we've drawn there in blue is the regression line. By writing the equation of this line, which we should be able to do, we can obtain a model for the data and make predictions. So we can predict the mortality of children under the age of 5 for points other than the ones that we've gathered. Data often fall on or near a line. In this section, we will use functions to model such data and make predictions. So what is the slope of a line? Mathematicians have developed a useful measure of the steepness of a line. It's called the slope of a line. Slope compares the vertical change, the amount the line rises, to the horizontal change, the amount the line changes in the x direction, which we call the run, when moving from one fixed point to another along the line. To calculate the slope, we use a ratio that compares the change in y, the rise, to the corresponding change in x, the run. So in our graph down here at the bottom of the slide, we have a line that's drawn through 2 points. One point we label x sub 1, y sub 1. That just simply tells us that it's the first point we're looking at on the line. So we label it with a subscript 1. The second point on the line is x sub 2, y sub 2. So the subscript 2 means simply that it's a second line, a second point on the line of this function, on the graph of this function. All right, so if we look at the distance, the vertical distance that this function's graph rises, so the distance here, right here, that is the rise. And that distance is just y sub 2 minus y sub 1. And then if we look at the distance in the horizontal direction to get from the first point to the second, that is this distance right here. We call that the run. So we can create an equation for the slope of a line. The slope of a line through the distinct points x sub 1, y sub 1, and x sub 2, y sub 2 is the change in y divided by the change in x, which is the ratio of the rise to the run, and we can write that as the distance from one point to the next in the vertical direction, so y sub 2 minus y sub 1, divided by the distance in the x direction, which is x sub 2 minus x sub 1. So if I know 2 points on the graph of a line, I can find the slope of that line by a simple substitution. Now we can't have x sub 1 and x sub 1 and x sub 2 being the same value. If x sub 2 equals x sub 1, then the denominator of this equation is 0, and dividing by 0 is undefined. So here is our definition of slope. The slope of the line through distinct points x sub 1, y sub 1, and x sub 2, y sub 2 is m, and m is the variable that we typically use for the slope of a line. M is equal to the change in y over the change in x, which is the rise over the run, which is given by formula, the difference in the y values of the 2 points, y sub 2 minus y sub 1, divided by the difference in the x values of the 2 points, x sub 2 minus x sub 1. And x sub 2 minus x sub 1 cannot be 0. Otherwise, we have division by 0, and that is undefined. So let's look at an example. Let's find the slope of the line passing through the points 4, -2, and -1, 5. Now, what I typically do is I label each point as either x sub 1, y sub 1, or x sub 2, y sub 2. So I'm going to let this point 4, -2 be my x sub 1, y sub 1. So x sub 1 is 4, and y sub 1 is -2. And I'm going to label the second point as my x sub 2, y sub 2. So -1 is x sub 2, and 5 is y sub 2. So x sub 2 is -1, and y sub 2 is 5. And then I make the substitutions. So the slope is going to be y sub 2, which is 5, minus y sub 1, which is -2. So since I'm subtracting a negative, I put that negative inside parentheses so I can keep my signs correct. Divided by x sub 2, which is -1, minus x sub 1, which is 4. So I have 5 plus 2 over -1 minus 4, or I have 7 over -5. Now I can write a fraction that's negative. I can put the negative in the denominator. I can put the negative in the numerator. Because when I divide a positive and a negative, I get a negative. I could also write it as -7/5. So you can put that negative in the denominator. You can put it in the numerator. You can put it outside the fraction. -7/5 is 7 over -5, or -7 over 5. All right, so the slope of this line is -7/5. All right, let's see what this looks like in the coordinate plane. Let's plot these points and look at the slope. Okay, so my 2 points are 4, -2, and -1, 5. So let's plot those 2 points. So 4 in the positive x direction, -2 in the y. So there's 4, -2 right there. And then let's graph -1, 5. So to the left 1 and up 5. And let's look at the rise over run. Okay, so the rise is the distance it takes me to get from one point to the next. And the rise there is 7, but I'm going down. So to get from 5 to -2, that distance is 7, but I have to go down from 5 to -2. So my rise is negative. I'm going down. And my run is the distance to get from -1 to 4. So my run, that distance is 5. And I'm going in the positive direction. To get from -1 to 4, I would be going along the x-axis in the positive direction. So the rise is negative because I'm going down from 5 to -2, and the run is positive because I'm going from -1 to +4. I'm going to the right. All right, so what are the possibilities for a line's slope? The slope of a line is positive, and that's how we designate that it's positive. Numbers that are greater than 0 are numbers to the right of 0 on the number line, and numbers to the right of 0 are positive numbers. So if the slope is positive, that means that the line is rising from left to right. So as x gets bigger, so does y. So the rise is positive. The slope is negative, and we designate that by saying that m is less than 0. Numbers that are less than 0 are to the left of 0 on the number line, and those are the negative numbers. If the slope is negative, that means that the line falls from left to right. So to get from one point to the other, I have to go down and to the right. So that would mean that the rise is negative, the run is positive, the slope would be negative. A horizontal line has a slope that is equal to 0. Every horizontal line has a slope that is 0. If a line is vertical, then its slope is undefined. Now, why does that work that way? Well, let's first look at the horizontal line. Let's say I have some point here, x sub 1, y sub 1, on this horizontal line. And let's say I have another point over here, x sub 2, y sub 2. And if I find the slope, well, the y values on a horizontal line are constant. This is the equation of a line where y is always the same number. It's constant. So y sub 2 and y sub 1 are exactly the same number. So the slope would be 0 over x sub 2 minus x sub 1. When you have a fraction whose numerator is 0 and the denominator is not 0, then that is 0. So a horizontal line slope is 0. Well, how about a vertical line? Again, what's the slope? If we look at a vertical line, every x value on a vertical line is a constant. So we could label this x sub 1, y sub 1, and this x sub 2, y sub 2. But x sub 1 and x sub 2 are exactly the same number. So what happens is we divide by 0, and we can't do that. That is undefined. So the slope of a vertical line is undefined. All right, so now let's get a couple of forms of the equation of a line. The first form we're going to derive is the point-slope form of the equation of a line. And why do you suppose it's called point-slope? Because when we derive this equation, this formula, if you know one point on your line and its slope, you can find the equation of the line. All right, so we can use the slope of a line to obtain various forms of the line's equation. For example, consider a non-vertical line that has slope m and that contains the point x sub 1, y sub 1. So we can use our slope formula to find the equation of this line. So the slope is the rise over the run, the change in y divided by the change in x. So if we look at this down here, they have defined for us that the change in x is x sub 1 minus, x minus x sub 1. xy is just some arbitrary point on the graph of the line, and x sub 1, y sub 1 is a point you know. You know what that point is. So I can write the run as x sub 1, x minus x sub 1 is how I want to write it. That is the run, x minus x sub 1. And the rise we can write as y minus y sub 1. So this distance is the point y minus the point y sub 1. Okay, so we can write that up here. All right, so now I have m equals y minus y sub 1 over x minus x sub 1. And I can multiply both sides by x minus x sub 1 to clear that fraction on the right-hand side. Okay, so now I have m times x minus x sub 1. On the right-hand side, the x minus x sub 1 cancels. And then I'm just going to rewrite this by using the reflexive property of equals. So I'm just going to flip it around. And I'm going to write y minus y sub 1 equals m times x minus x sub 1. So if you know a point on the line, some x sub 1, y sub 1, and you know the slope of the line, you can find the equation of that line. The point slope form of the equation of a non-vertical line with slope m that passes through some point x sub 1, y sub 1 is y minus y sub 1 equals m times x minus x sub 1. This is the point slope form because what are the two things you need to know to find the equation of the line? You need to know the slope m, and you need to know one point, some x sub 1, y sub 1. All right, so write an equation in point slope form for the line with slope 6 that passes through the point 2, negative 5. Then solve the equation for y. So when you're solving these problems in MyMathLab, you're going to input two different answers. The first answer you're going to input is the equation in point slope form. So you're going to leave it in the form with the parentheses intact, all right? And I'll show you what I mean in just a second. The second answer you're going to input is the equation solved for y. So you're first just going to input m and the point into the point slope form of the line, and then you're going to solve for y and get the equation written in terms of y equals. All right? So what is the point slope form? Y minus y sub 1 equals m times x minus x sub 1. That is the point slope form. And you know two things. You know that the slope is 6, and you know one point on the line is 2, negative 5. So we're going to make those substitutions. So we have y minus a negative 5 equals 6 times x minus 2. So where there was a y sub 1, I replaced it with a negative 5. Where there was an m, the slope, I replaced that with 6. Where there was x sub 1, I replaced that with 2. And I'm just going to remove the parentheses in front of the negative 5, so I can write this as y plus 5 equals 6x minus 2. And that is point slope form. So in MyMathLab, when it asks you for the point slope form, this is what they want right here. All right, so the second thing they ask you is to go ahead and solve this equation for y. So to solve this for y, you're going to remove the parentheses, then you're going to combine like terms if you have any, and then you're going to get the 5 from the left-hand side of the equation to the right-hand side of the equation, so that you can have the equation in the form on the left-hand side just y, and on the right-hand side an expression using x. All right, so we're going to first remove the parentheses using the distributive law. So we're going to distribute the 6 across the x. 6 times x is 6x. Then we're going to distribute the 6 across the negative 2. 6 times negative 2 is negative 12. All right, so we have y plus 5 equals 6x minus 12. Then I'm going to move the 5 to the right-hand side of the equation by subtracting it from both sides. Negative 12 minus 5 is negative 17. So there is the equation solved for y. So first, I put it in point slope form. So I'm going to leave it with the parentheses just in that form. And then I'm going to actually remove the parentheses and get the constant that's on the left-hand side to the right-hand side so I can solve this for y. So there are 2 answers to these questions in MyMathLab. Write an equation, got a typo right there, write an equation in point slope form for the line passing through the points 4, negative 3, and negative 2, 6. So what's my point slope form again? Y minus y1 equals m times x minus x1. All right, so what are the 2 things that I need to know? I need to know the slope of this line, and I need to know one point. Well, I have points, but I don't know the slope. So I'm going to have to determine what the slope is. So I'm going to use the slope equation to find the slope. Once I have the slope, then I can take that in one of these points, and it does not matter which point you use. If those are both points on the equation of this line, then it doesn't matter which point you use to find the equation of the line. Okay, so I'm first going to find the slope, which is the change in y over the change in x. And I'm going to let this be the point x sub 1, y sub 1. So x sub 1, write it over here, x sub 1 is 4, and y sub 1 is negative 3. And I'm going to label this point x sub 2, y sub 2. So x sub 2 is negative 2, and y sub 2 is 6. And then I'm going to make these substitutions. So the slope is going to be 6 minus a minus 3 divided by negative 2 minus 4. So that's going to be 9 over negative 6, which I can simplify. I can cancel out a 3. So it's negative 3/2. So the slope of this line is negative 3/2. And I kind of have the negative written in front of the 3. Again, if you have 3 over negative 2, you can write that minus in the numerator or the denominator or outside the fraction. Typically, we would write negative 3/2. They all mean the same thing. All right, so now that I have the slope, I can substitute back into the point slope form and find the equation of the line. Okay, so we're going to make that substitution, and I can use the first point since I labeled that x sub 1, y sub 1. Why not? So we have y minus a minus 3 equals negative 3/2 times x minus 4. Let's just rewrite this slightly. Minus a minus 3 would be plus 3, minus 3 halves, x minus 4. And that is point slope form right there. That's all you need to input when it's asking for the equation in point slope form. Now, the second part of this question, they're going to ask you to solve for y. So again, we're going to remove parentheses, and then we're going to move the positive 3 to the right-hand side of the equation. So we have y plus 3. We're going to remove the parentheses by distributing the negative 3 halves across. Negative 3 halves times x is negative 3 halves x. Negative 3 halves times negative 4 is going to be plus. And you can use your calculator if you can't do that in your head. The 2 will cancel with a 2 and the 4. 3 times 2 is 6. So negative 3 halves times negative 4 is positive 6. All right, so now we're going to move the positive 3 to the right-hand side of the equation by subtracting it from both sides. And here is our equation solved for y. So we get y equals negative 3 halves x plus 3. And again, I'm being sloppy with that negative. I technically probably should put it outside the fraction like this. But again, if you have a negative fraction, that negative could go in the numerator. It could go in the denominator, one or the other, or it can go out in front of the fraction. So when you divide a positive by a negative, you get a negative. So it doesn't matter if you divide the numerator's negative and you divide it by a positive denominator, or if you have a positive numerator and you divide it by a negative denominator, you're going to get a negative fraction. Okay, now let's look at slope-intercept form. We have just derived and used the point-slope form of the equation of a line. Now let's get slope-intercept. So what does this imply if we call it slope-intercept? It implies that looking at the equation, you should be able to determine the slope of the line, but you should also be able to determine the y-intercept. So let's derive this equation from this image we have here on the slide. Okay, so we know that a function has a y-intercept, and we can call that intercept b. Why not? I mean, we could call it a lot of things, but we're going to call it b. So the graph of this line intercepts the y-axis at 0b. Its y-intercept is b. It goes through the point 0b. An arbitrary point on this line is some xy, and the slope of this line is m. So xy is just some arbitrary point. Remember, what do we use variables for in algebra? We use variables to represent an unknown, so it's some point on the line that we don't know. Okay, so now we're going to use the point-slope equation to find the equation of this line. So we have y minus y1 equals m times x minus x1. And the point x sub 1, y sub 1 that we're going to use is the slope-intercept. Excuse me, the y-intercept. I think I said slope-intercept. The y-intercept. And the y-intercept is 0b. So x sub 1 is 0, and y sub 1 is b. So we're going to make that substitution. You have y minus b equals mx. X minus 0 is just x. Then we're going to add b to both sides. And we get the slope-intercept form of the equation of a line. So when your equation is solved for y, which we did on our previous examples, we took the point-slope form and then removed the parentheses and solved for y. We were putting those equations in slope-intercept form. And it's called slope-intercept form because by just looking at the equation, you can determine what the slope is. The slope is the number you're multiplying times x, and you know what the y-intercept. The y-intercept is the constant you're adding to that x term. So the slope-intercept form of the equation of a line, a non-vertical line, with slope m and y-intercept b is given by y equals mx plus b. So looking at these two examples, y equals 2x minus 4, just looking at that equation, I know the slope is 2 because that's the number I'm multiplying times the x. So the slope is the number that you're multiplying times your variable x. The y-intercept is whatever that constant is. So the y-intercept is -4. This second equation, we did write this in terms of a function, lines except for vertical lines. All lines except vertical lines are functions. A vertical line fails the vertical line test spectacularly. So a vertical line is not a function. So we could write this linear equation using our function notation, f of x equals 1/2 x plus 2. So the number I'm multiplying times x is 1/2, so the slope of this line is 1/2. The constant that I'm adding to that term is 2, so the y-intercept is 2. All right, we can use slope-intercept to graph the equations of lines. We simply plot the y-intercept, and then we use the slope, the rise over run, to find a second point on the graph. All right, graphing y equals mx plus b using the slope and y-intercept. Number 1, plot the point containing the y-intercept on the y-axis. This is the point 0b. 2, obtain a second point using the slope, m. Write m as a fraction. So if m is an integer, you're going to write it as itself over 1. And use the rise over run starting at the point containing the y-intercept to plot the second point. Then use a straight edge to draw a line through the 2 points. Draw arrowheads at the end of the line to show that the line continues indefinitely in both directions. Okay, so we're going to graph the linear function f of x equals 3/5 x plus 1. So the first thing you do is you plot the y-intercept. So since my constant on the right-hand side of this equation is the number 1, the y-intercept is 1, so we plot the point 0, 1. Now we're going to use the slope, which is the 3/5, to determine a second point. So what does the slope tell us? The slope tells us the rise over run. So it tells us how much we're going to go up from that point and how much we're going to go in the x direction from that point. Now, if it's negative, we'd go down and to the right. If it's positive, we're going to go up and to the right. All right? So since the rise over run is 3/5, from our y-intercept 1, we're going to go 3 units up. 1, 2, 3. And since the denominator of our slope is 5, the run is 5, so we're going to go to the right 5 units. 1, 2, 3, 4, 5. So the point we end up at, since we've gone up 3 and to the right 5 from 0, 1, we're going to plot the point 5, 4. We've gone up 3 units from 1, so our y-coordinate is 4. 1 plus 3 is 4. And we've gone to the right 5 units, so the x-coordinate of our point is going to be 5. So we now have 2 points. We can draw a straight line if we have 2 points. So we take our straight edge out, and we draw a line between those 2 points. So you use the intercept to find the first point. The intercept is the first point. And then you use the slope to find the second point. Typically what we do, if the slope is positive, I can't spell it. we go up and to the right. If the slope is negative, we go down and to the right. Now you could technically go up and to the left. That would still be negative. If you go up, that's positive, left is negative. So you could do that too. So you could also go up and to the left. You could do either one because both of those would give me a slope that's negative. If the rise is negative, we're going to go down. If the run's positive, we're going to go to the right. Or if the rise is positive, we could go up and we could go left, which would mean that the run is negative. And again, a negative fraction, you can put the negative in the numerator, you can put it in the denominator. It doesn't matter. All right, horizontal lines. A horizontal line is given by an equation y equals b, where b is equal to the y-intercept of the line. The slope of a horizontal line is 0. So the equation of a horizontal line is y equals a constant, and that constant is equal to the y-intercept. If it's a vertical line, the equation of a vertical line is in the form x equals a, where a is the x-intercept of that line. So the equation of a vertical line is equal to x equals a constant, and that constant is the x-intercept. The slope of a vertical line is undefined. A vertical line is not a function. A horizontal line is. A horizontal line will pass the vertical line test. A vertical line will fail the vertical line test at every single solitary point. Okay, so graph y equals 3 in the rectangular coordinate system. The equation y equals 3 is a horizontal line. So you just plot the y-intercept at 3 and then draw a horizontal line through that point. So plot the y-intercept equal to 3 and then draw a horizontal line through that point. The general form of the equation of a line is the form when you get everything on the left-hand side and 0 on the right. Every line has an equation that can be written in the general form ax plus by plus c equals 0. A, b, and c are all real numbers, and both a and b cannot equal 0. So this is an equation of a line in general form. We have the x and the y and the constant on the left-hand side and 0 on the right. And this form of the line's probably the least helpful of the forms we've looked at, because you can't just look at the line and determine the slope and the y-intercept. So what do you have to do to be able to determine the slope and the y-intercept? You have to get the equation of the line in slope-intercept form. So what you have to do is you have to solve this for y. So how do we solve this for y? All right, the first thing I'm going to do to solve this for y is get the negative 12 to the right-hand side. So I'm going to add 12 to both sides. The next thing I'm going to do is get the positive 3x to the right-hand side by subtracting it from both sides. And I'm going to rewrite the right-hand side as negative 3x plus 12. All right, the last thing I'm going to do is divide both sides by 6. And now I have the y isolated. Now we know if we divide a numerator by a single denominator, a monomial denominator, then I can write each term in the numerator over that denominator. That's how you learn to add fractions back in the 4th or 5th grade. You might not remember that, but that's what you did. Okay, so now I can simplify. I can cancel a 3 in the numerator and denominator of that first fraction. So I get negative 1/2 x, and then 12 divided by 6 is 2. So now I have this equation in slope-intercept form. So I can just look at it and determine what the slope is. The slope is the number that I'm multiplying times x. So the slope is negative 1/2. And the y-intercept is 2, which we could also write as 0, 2. All right. Using intercepts to graph. And this is my personal favorite way of graphing, that and slope-intercept. But a lot of the problems that you'll be given in MyMathLab to graph lines, this is probably the fastest way to do this. And when we later talk about linear inequalities later in the course, this is probably the fastest and easiest way to graph those. All right, using intercepts to graph ax plus by plus c equals 0. So the graph, the equation of a line in general form. First of all, you're going to find the x-intercept. To find the x-intercept, let y equal 0, because if it's on the x-axis, the value of y is 0. Let y equal 0 and solve for x. Plot the point containing the x-intercept on the x-axis. To find the y-intercept, you're going to let x equal 0. Again, if you're on the y-axis, x is equal to 0. Let x equal 0 and solve for y. Plot the point containing the y-intercept on the y-axis. Use a straight edge to draw a line through the 2 points containing the intercepts. Draw arrowheads at each end of the line to show that the line continues indefinitely in both directions. Okay, graph using intercepts. 3x minus 2y minus 6 equals 0. All right, to find the x-intercept, you are going to set y equal to 0. To find the y-intercept, you are going to set x equal to 0. Now, I fudge this a little bit, and I add the 6 to both sides to get this in a slightly different form. It just makes solving the equation easier. So I always move the constant back to the right-hand side of the equation. It makes it so much easier to deal with, because then I don't have to add the 6 to both sides every time I find an intercept. So I'm just going to go ahead and do that. I'm going to add 6 to both sides. So I'm going to get the constant over on the right-hand side of the equation. So I get 3x minus 2y equals 6. So much easier to deal with. So now let's find the x-intercept. To find the x-intercept, you are going to set y equal to 0. So you're going to get 3x minus 2 times 0 equals 6. 2 times 0 is 0. So you get 3x is equal to 6. Divide both sides by 3. And you get x is 2. So your x-intercept is the number 2. So you go on the x-axis and you plot the point at x equals 2. Okay, to find the y-intercept, you're going to set x equal to 0, because if you're on the y-axis, the x value, every x coordinate on the y-axis is 0. So you're going to set x equal to 0. Three times 0 is 0, so you have minus 2y is 6. Divide both sides by -2, and you get y is -3. So then you're going to go to your coordinate plane, and you're going to plot the point y equals -3 on the y-axis. Okay, so what were our x-intercepts again? We had an x-intercept at 2. We had a y-intercept at -3. I take my straight edge out. I connect the points. I draw arrows on each end. I could label these points. That's 2, 0. That's 0, -3. To me, it's the easiest way of graphing the equation of a line. Okay, so here's a summary of all our equations of lines. The point-slope form, you need to know the slope and one point on your line to find the equation of the line. Slope-intercept form, you need to know the slope and the y-intercept to find the equation of a line. A horizontal line is an equation where you get y is equal to a constant, or f of x equals that constant because that is a function. A horizontal line is a function. A vertical line is in the form x equals a constant, not a function. And the general form is when you have everything on the left-hand side and 0 on the right. All right, let's use everything we've learned to create a model. Use the data points 317, 57.04, and 354, 57.64 to obtain a linear function that models average global temperature, f of x, for an atmospheric carbon dioxide concentration of x. So our input x is the atmospheric carbon dioxide concentration, parts per million, round m to 3 decimal places and b to 1 decimal place. So we're going to create a model for our data. So the first thing we need to do is find the slope. And we're given 2 points, so we can use those 2 points to find the slope. So we can call the 317, 57.04, we can call that x sub 1, y sub 1. And the other point, 354, 57.64, we can call that x sub 2, y sub 2. All right, let's find the slope. And I'm going to need my calculator for this, I suspect. So that's going to be 57.64 minus 57.04 divided by 354 minus 317. So if I take my calculator out and do this calculation, I get approximately, and I'm going to use a squiggly equals to show that this is approximate, 0.016. So it told me to round the slope to 3 decimal places, and that is 3 decimal places. The 10th place is the first 0. The 100th place is the 1. The 1000th place is the 6. So this is rounded to 3 decimal places. I have 3 numbers to the right of my decimal. Okay, so now I have the slope. I can use the point slope equation because I have 2 points. I can pick either one, and I have the slope, so I can find the equation of the line. So we have y minus y1 is equal to the slope times x minus x1. And it doesn't matter which point I use for x sub 1, y sub 1. It doesn't matter 1 iota. So I think I used what I used over here, the 317, the 57.04, but you can use both of them. So we have y minus 57.04 is equal to our slope, which we determined, x minus 317. All right, so I'm going to take my handy dandy calculator out to help me with this distribution on the right. So I'm going to multiply 0.016 times 317, and I get 5.072. Now I'm going to isolate the y. So I'm going to add the 57.04 to both sides. Oh, I forgot my x right there. Sorry about that. 0.016x. And then we're going to have 0.016x, and I take my calculator out, and I add 57.04 and negative 5.072, and I get 51.968. And they told me to round off the y-intercept to the nearest whole number, I believe is what they said. 1 decimal, b to 1 decimal place. So if I round the second number, the b, to 1 decimal place, I'm going to round up the 9, but that's going to round up to 10. So it's going to round up to 52.0. Because if to round off to the 1 decimal, you look one number to the right, that's 6, that's bigger than 5. So you're going to round the 9 up. But when you round that up, you have to round the 1 up to 52. So it's 52.0. And there is our model of atmospheric carbon dioxide, which I can't say. All right, and that is the end of section 2.3.